Or the diagram below shows two pentagons, P and Q, drawn on a grid made up of squares. It says select which one of them is correct. These are opposite, no. Opposite, no, I don't know what they're talking about here. Reflected, this is not reflection, no. Congruent, yes, they are congruent. As you can see that the area of P would be the same as the area of Q. We can see that their shape is also the same. All right, it's just that they have different orientation. Translated, no. So now what we can just put, the best option is congruent. These two are congruent. Pentagon P is congruent to pentagon Q. Why are they congruent? All right, let me reduce the font size just a little bit. Why are they congruent? They are congruent since they have the same shape and area. How do I know they have the same area? Because each sides are the same. If you look at this vertical side right here, or this horizontal side right here, and this side right here, they're the same. So they have the same shape and they would have the same area. The area of P is equal to the area of Q. It's just that one of them is rotated, all right, so to speak. They have a different orientation. Well, they're the same thing. All right. This question says, the diagram below is not drawn to scale. And it says, it shows we have a pentagon here. And in the pentagon, YZ is parallel to XW. All right, once there are two parallel lines, we can start to think about co-interior angles and stuff like that. And YX is parallel to VW. Angle XYZ is 114, while angle VZW is 98. And it says we are supposed to find what is angle WXY. Angle WXY. Angle WXY is this one right here. Now look at this. Since VW is parallel to YX, then co-interior angles sum to 180. Co-interior angles sum to 180. Since co-interior angles sum to 180, that means 114 plus this is 180. So that can give us the angle right there. So we can use that and we're good. So what we're going to tell them is WXY plus 114 is equal to 180. We put in bracket, co-interior angles are supplementary. I can just write co-interior angles. They'll know what you mean. Co-interior angles. Just extend this a little bit. They'll know what you mean when you say co-interior angles. And all we need to do now is transpose. So that means say angle WXY is equal to 180 minus 114. And so you subtract them there. Just to not give it away, I'll use a calculator for safety. 180 minus 114, that's 66 degrees. 66 degrees. All right, now it want angle ZVW. Angle ZVW. So they want this angle right here. This angle they want. Now we know that co-interior angles are supplementary. So also know that this angle will be 114, right? We know so this is 114. We know this, but guess what? This is a pentagon. What do you know about a pentagon? Sum of all angles in a pentagon is 540. Sum of all angles in a pentagon equal 540 degrees. So since that is the case, we know all of the angle them. We know all of the angle them though. Yeah, we know all of the angle them. Since we know all of the angle them, all you have to do is add them up. So we can tell them say 98 plus 114 plus the 114 plus the angle here, which is 66, plus now the angle we want, which is Z, V, W, we know so that equal 540. So I'm going to add up everything on the left-hand side in my calculator. 66 plus 114 plus 114 plus 98. I add them up, I get 392. So what I'm pretty much saying then is 392 plus the angle we want, which is ZVW, is equal to 540. And then we can subtract, and so angle ZVW is going to be equal to, let me just get some space here. So angle ZVW is equal to 540 minus 392. You punch that in a calculator, 540 minus 392, I'll get 148. That is equal to 148 degrees. All right, that's the answer right there. Oh, nice. That's it. All right, let's move on. This question right here now, it's a transformation question. It says the letter A and the point C are shown on the grid. This is your point C, and this is your letter A. It says, on the diagram, draw accurately the following. Number one, the letter A by a scale factor of 2 about the center 6, 6. Now, what I'm gonna do is, I don't like anything about center 6, 6, right? So what I'm gonna do for now is I'm gonna just move the center. I'm gonna move the center of enlargement to the origin. I like to work with everything from the origin. This is, as I can see right here, if I move the center of enlargement from the origin, if I move the center of enlargement to the origin, what that means is this coordinate right here, so it is 2 units, 2 units across, 2 units down. So from the origin, what I'm gonna do is go 2 units across, 2 units down. This would be the start of A. This one right here, so is, let me see, 1, 2, 3 units across and 4 units down. So from the origin, 3 units across and 4 units down. 1, 2, 3, 4. And then I'm gonna go one unit across and 4 units down. 1 unit across, 4 units down. This would be where A would be. This would be where A would be if it was, say, the center of enlargement C was at the origin. So now what I'm going to do is magnify this now. To magnify these points by a scale factor of 2, I'm going to multiply them by 2. So what I'd end up get is, when I magnify it by 2, it would become minus 2 times minus 2. When I multiply that by 2, it becomes minus 4 minus 4. Minus 4 minus 4 would be right here. And then when I magnify this point by 2, it would become minus 3. Let me see. Minus 3 would become minus 6. And then the minus 4 part would become minus 6 minus 8, somewhere down here. So minus, wait, 2 times, yeah, minus 6 minus 8, somewhere down here. So minus 6 minus 8. So let me put it in bracket, minus 6 minus 8. It's not on a graph because this point, this is not going to be the final answer. All I'm doing is I'm moving. First thing I did, just to slow it down a bit, what I'm doing is moving the center of enlargement to the origin for now. I'm just moving the center of enlargement to the origin. Let me put a note. I moved the center of enlargement to the origin. Because that's what we're used to. By moving it to the origin, that means that we move A to Yaso. This is how we move A to Yaso. Then we are going to magnify that A there. Magnify that A with a scale factor of 2. That's what I'm doing now. So look, remember, this is the distance from A to the center of enlargement. So if I move it over, translate it to the origin, this is where A would have been. So ignoring this one for now. So then now when we magnify this point by a scale factor of -2, so -1 times 2 would become -2, -2, -8, which would be somewhere right here. Now, once I get this answer, this would be your new magnified A, right? Now, what that's gonna then do is, but even though this would be now the enlarged answer, this would be now the enlarged answer, something like this. What you need to then do is translate it. You need to translate it now. What do you mean by translate it? You have to bring it back to the center being 6, 6. So to bring it back to the center being 6, 6, what we're gonna then do is add 6 to each point. So this point right here, which is -4, you're gonna add 6, 6 to it. So if you add 6 to this point right here, so add 6 to it, 6 plus -4 is, 6 plus -4 is what? 2. And then 6 plus -4 is 2. So the new point is gonna be 2, 2, that's gonna be 1. Then this new point, -6, -8, when I add 6 to this now, -6 plus 6, that's 0, so the x value is 0. -8 plus 6, that's -2. So this is going to be it. And then right here, so now, -2. -2 plus 6 is 4. That's going to be 4 over here. And then this is -2 -8. Why was this like this? And then when I add this now, add 6 to this, that's -2. So that's 4 negative. That's 4 -2. All right, so that's your final answer. And now we're gonna put that on the graph now. So put this on the graph, this is how it gonna look. These are the actual answer now. So I'm gonna put it in all black too. Make it to say this is the answer. All right, so all I did was move it. Dum, 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 dum. This would have been the actual A now. 1 unit, so this is 2 units. This would have been the actual A being enlarged. All right, so this is part 1. So all we do is remove them here. We don't need these no more. That's the actual answer. So what I'd recommend you to do is this in a like a dotted line or something. So you can rub it out. But we never need all of them there. These are the final answer now. That's the final answer, this. All right, so this is part 1. Done and dusted, nice. All right, this would be enlarged with a center of enlargement being 6, 6. Just to verify that it's the center of enlargement, what if it stays, all right? And you draw like one line passing through the image and the object point. It's supposed to pass through the center of enlargement. So just a check out, see if that happens. Yes, them are pass through the image point and the object point and the center of enlargement. So okay, I can say, yeah, man, it definitely makes sense. It is indeed true. The center of enlargement is now 6, 6. So now I've not to worry about, that is that. Now the next part says we need to translate A. Translation of the letter A using the vector t equal -3, 2. -3 meaning go to the left. 1, 2, 3 to the left. Then 2 meaning go up in the upward direction. 1, 2. So this gonna be how we translate this point. Now we need to translate this point. -3 to mean to the left. 1, 2, 3. Then we'll go up 2. 1, 2. Right here. So then we're gonna translate again. -3 means to the left. 1, 2, 3. Then we'll go up 2. 1, 2. That's it. And then we're just gonna draw that now. Let's use different color for that one. Let's use red. The red one is for the translation. The black one is for the enlargement. That's it. Red one is for the translation. The red one is for the translation. And the black one is for the enlargement. All right, nice. I just put TE to show you which one. This is a translation, this is the enlargement. And that's it, that easy, 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 easy. Nice.